All right, so for our project, we found a case study. It was the quantification of pollutants in eastern South Dakota. It was a 3-year sample period, and the size of the research sites ranged from 7.18 to 18.69 acres. All sites had crops of corn, oats, pasture, or hayland. Composite samples of the runoff were used for various chemical, physical, and biological determinations. Runoff samples from 108 snowfall events and 36 rainfall events were collected. Equipment fabrication and installation resulted in some incomplete data, but successful monitoring of each runoff event was accomplished thereafter. So they managed to work through any issues they had. It was completed in 1973 by the South Dakota State University under sponsorship of the EPA. So long time ago, but it was a pretty big deal back then, which is why we're using it. So I'm going to jump into the results, and then I'm going to get back into a little bit of the specifics. So they found that nutrient loss ranged from 0.03 to 3 pounds per acre per year of nitrogen, and there was 0.01 to 0.72 pounds per acre per year of phosphorus. So quite a big range. But most of the annual nutrient load comes from snowmelt runoff, and a large percentage of this is in a soluble form, which is something we talked about earlier in this video. So in areas comparable to those of the study, soil conservation practices, reducing surface runoff from like melting snow probably won't be effective for solving lake eutrophication from the nutrients in agricultural runoff is something that they found. Annual soil losses were pretty low. They were expecting them to be a lot higher, but they ranged from less than 10 pounds per acre per year up to 1,000, and rainfall accounted for almost all of this at 93.7%. And the bulk of this loss occurred during high intensity rainstorms. So the force of the impact of the rain led to the most soil erosion. 1/3 of total runoff was caused by rainfall, so snowmelt contributed to most of it. And pesticides were largely below the limits of 0.05 parts per billion for aldrin, DDE, Teldrin, Lindane, and others, and below the limits of 0.10 parts per billion for DDT, DDD, and atrazine, and methoxychlor. Total coliform and fecal coliform densities in runoff frequently exceeded limits, however, and highest counts were attributed to cultivated fields, so farming. Additionally, they found that permanent grass fields had comparable quantities to cultivated fields, but the runoff was mostly from snowmelt rather than rainfall. There's grass holding the soil down, so there's going to be less soil erosion than you would find in cultivated fields. And fall plowing could reduce the snow retained on fields, which reduces runoff from rainfall, but it'll increase the erosion potential overall. So specific locations, these are the two that we're going to be using throughout the rest of our tutorial videos and in some example problems. So there was a 173-acre cultivated site, which found 2,040 pounds per acre per year of suspended solids, 6.9 pounds per acre per year of BOD, 246 pounds per acre per year of COD, 8.4 pounds per acre per year of total nitrogen, and 0.07 for total phosphorus. And then there was a 27-acre residential area, which found 730 pounds per acre per year of suspended solids. 22% were volatile, 33 pounds per acre per year of BOD, and 240 pounds per acre per year of COD. So you can compare the two right there. And for a much smaller area, it had pretty comparable numbers, 240 to 246 pounds per acre of COD. And we're missing a slide. Okay, there it is. So this is a table taken from the case study, It shows separate sites, so land use such as like forest and grazing area, farmland, forested, diversified farming, research plots, orchards. And it tells you whether there's a stream flow or a surface runoff. And then it has the values for nitrogen and phosphorus and some little remarks. So you can see here that just like the farmland had pretty high total nitrogen, the research plots in the orchard had a very high total nitrogen. And you can just see the range of sites from there. So it was a really interesting paper. It had a lot of detail about each specific site. They had a couple of different people and organizations working on it. So the paper goes through each of their contributions. So it's really informative, and it is listed in our references, it's number 3. So thank you, and we'll jump into the quiz.